Thanks for attending our presentation. I'm Tianwei Chen, a PhD student at Osaka University. Today I will present our paper Would deep generative models amplify bias in the future models. Recently, many works have shown that deep generative models, such as Stable Diffusion and the DALL-E 2, contain social bias. However, generative images are becoming more and more on the internet. This situation could bring toxic effects in many ways, such as stereotyping, less representations to the minorities, and even improper representations to them. In this paper, we're focusing on one scenario that how the deep generative models would affect future models, especially when generated images are increasingly involved in the training data. More straightly, would they amplify bias in the future models? To answer this question, we first make simulations of such data contaminations. Here, we use Stable Diffusion to generate images and randomly replace some of them in the training data. We then train models with this dataset and evaluate the challenges in gender, skin tone, age, and ethnicity. We make our experiments on the assumptions that generative images are increasingly involved in the future training data. Captions from the original data are used as they are as the prompt, and the generated images are not filtered. Based on these assumptions, we explore two types of models. One is the image text pre-training models such as OpenClip, which is widely used for many downstream tasks. Another one is the image captioning models such as ClipCap, which aims to learn how to generate content during the training. Due to the time limitation, we can only show some selected experiments, and we will introduce the bias matrix with them. The first one is image retrieval with different groups of people. Given captions associated with different groups, we ask OpenClip to retrieve the correct images by these captions. And the gap between the performance indicates the bias on OpenClip. In this experiment, we find that the change of bias differs a lot, containing bias mitigation, application, no significant change, and ambiguous changes. In the second experiment, we evaluate OpenClip on person preference. This metric aims to find how OpenClip prefer to use a neutral sentence to describe a photo of a certain group of people. Similar to the image retrieval, the performance gap between groups indicates the bias of clip. The experiment shows similar results in that there's not a clear trend in the change of bias. However, we have an interesting finding that, although the changes in bias are not clear, the score of person preference has a trend. It looks like during the data contamination, OpenClip concerns less and less about gender and age, but more and more about ethnicity. Now we have following two findings. First, there are diverse trends in the bias changes, ranging from bias amplification to bias mitigations, which also means that the generative images do not always amplify bias. Second, OpenClip prefer to mark images with more ethnicity labels, but prefer to mark them with less gender and age labels. These results are contradictory, as none of the trends are consistent. We then wonder why this happened. First, we consider the quality and the inherent bias in the original dataset. As it has shown in the previous work, CC3M and COCO has already contained bias. In this case, if the bias in the original dataset is larger than the generated one, the bias of the model may be mitigated. Second, we notice the generation failures. For example, we find the deep generative models may generate images with blurry faces. In this case, it's hard for a model to learn facial features such as gender and age from the images. Also, we find that deep generative models can generate stereotyped contents by the certain words. So, based on the above experiment and analysis, we would like to make conclusions that first, the deep generative models may not always result in bias implication. Second, the bias in the original dataset and the generation failures in the deep generative models could affect the results. However, we consider that risks still remain and could affect future models, considering that the results are based on our specific experimental settings, which does not mean it will be the same for OpenClip training on the full training dataset. Furthermore, since some bias mitigation could be related to the generation failures, the development of deep generative models, such as less failures, could change the results. Thank you for listening. If you are interested, please also check our paper and GitHub for more details.